Remember we had that little chat yesterday about surds. Surds are a what are surds here? They're an irrational number. Yep, can't be written as a fraction. You've got two components. They've got this component called the radical. That's the radical. Okay, and then you've got the rational number under there. Okay, that's how we want to try and write our surds. 108. Square root of 108. Can we write that in a different way? 108 is what? 12 times 9?
36 times 3.
36 times 3? Lots of different ways you can do it, eh? But let's go 36 times 3. What's the square root of 36? So that's the same as 6 root 3. Okay? You happy with that? Next one, 98. X7, Y8. What do we do there? What's that one? What's 98? How does 98 works?
49 and 2.
49 times 2? Okay, that's 49 times 2, then that's the same as 7 root 2. Is that right? Remember this, x to the power of 7, what is that? That is x to the power of 6 times x, all to the square root, isn't it? X to the power of 6 is x to the power of 3 root x. Can you see that? And y to the power of 8 is just y to the power of 4. So this one here, as its surd, would be 7x cubed y4 square root of 2x. Like that. Here is the surd. You guys happy with that? Done something wrong? No? Okay. So as I said, we did those ones. So that is simplifying. Okay. So we come along here. My computer wants to. Why do you not want to? Come along. Here you go. Right. So can we do now some add sub with these particular equations now, or particular surds? Now this looks a little bit trickier, is that right? Okay. So let's try and simplify these a little bit further. So 18, how are we going to do those ones? What's the first step we're going to do?
Simplify all 3.
Simplify all 3 first. So that's going to be 9 times 2. So that's going to be 3 root 2. Is that right? Happy? What's the next one then? 2 root 5. And 3 root 5. Okay, now when we're adding and subtracting these, what do you think we can do?
Add 5 and 2.
The last two are root 5, root 5, so you can do 5 root 5.
Yeah, so that's going to be 3 root 2 plus 5 root 5. That's just a complex way of writing down like a question, like terms, eh? There are my like terms, if you like. So there's my answer. Would that be about right? Yeah. You reckon we can go any further? No. Oh, we'll leave it like that then, eh? Next one. What do you think about this one? Let's just try and simplify it, eh? Not 56 is what?
54.
Pardon?
54.
So 54, yeah. 9 and 6. So that's going to be what?
3 root 6.
3 root 6. Okay. 3 root 6. That a is going to be out the front, so it's going to be a squared b. Let's write that down as 3ab, a squared b, root b 6.
Isn't it?
Oh, no, wouldn't it just be?
No, yeah, just 3a.
It would just be 3a, wouldn't it?
Yeah. 3a root 6b.
It's going to be what?
Oh, because AB's already out the front.
We've already got an AB
Oh,
here.
I didn't say that.
So
Yeah, I
this
didn't
part
say that either.
here, we're happy with going to be 3 root 6
Yeah.
with well, AB, isn't it? Sorry, 6B
3A.
with the A at the front.
Yeah.
Yep. So that's why it becomes 3A squared B
I didn't see that.
times 6B root 6B. What's up? Happy with that? Is that?
You could go further.
What do you mean?
So you could put the B back in to the square root and make it like 2. Down the front, 3A squared B, if you put the B back in, it'll make it 6B cubed.
Let's do the other one over here. Let's go this way and go.
Settle for
What does that become? That's A squared B root 6B, isn't it? So try it rather than doing what you were saying, going that way. Simplify, because now we've got 3A squared B root 6B minus A squared B root 6B. We've just got 3 lots of something minus 1 lot of something. We've just got 2 lots of that something. That something, it just happens to be A squared B root 6B. Okay? That's why it's this easy maths about adding and subtracting like terms, but done in a pretty complex way. Is that fair? You guys happy with that? Any issues with that one?